We're going to bring everybody up for a panel and then have everyone ask their questions of whom they wish. So, Nurit, please take a seat. Mudit, Tarun, I encourage you to sit. Okay, so I have a few questions, but I want to hear from everybody. We covered a lot of ground. Does anybody have questions for any of our speakers? Please.
Yeah, I have a question for the room. So some of the matter available in my head, but if I got you correctly, the analysis.
Mike there.
Sorry, yeah. So I was saying, my understanding is the analysis showed that it was safe, like the attack was not viable, and therefore you could go and make the proposal to remove the pool or whatever the solution was.
Yeah.
I was wondering, did you have a path in case you found that the attack was actually possible, and what would you have done in such a scenario?
Yeah, that's a great question. In that scenario, I think we were just basically in the same process in tandem, basically talking to people who were lending in XSushi and basically telling the XSushi lenders who are actually at risk in the sense that they're the ones taking the biggest loss to just withdraw their assets. So it was kind of two things in tandem. One, trying to analyze security, figure out if this could happen, and then making sure the proposal was safe. But then two, like trying to encourage people to not lend in XSushi, and I think that was successful. I mean, you were around too, so he can also.
Yeah, I can add a little on that. So there was one possible path, which is FTX using their sushi to exploit it. We figured it was not a very practically viable path, but in the longer term, you don't want that risk at all.
Do you have another question? Please.
For Nurit, just wondering, what can you give an example of what your bug injection system looks like? Like you provide the elevator, just high level example of that.
Yeah, I think I didn't mention it, but yeah, mutation testing, first of all, is a good approach. The problem with mutation testing is not necessarily every mutation should be caught. I mean, some mutations are okay. They are not bugs. And we do actually a manual bug injection. We have someone that understands the system, insert bugs that we want to make sure those are caught.
So is that modifying just variables in the state?
Modifying variable, changing the code. A lot of the bugs that we have found, those are the ones that insert. Yeah, right. So confusion in the message sender and the user, and confusion about computation, bitwise operation, logic operation. All the things that we actually see as bugs, those are the ones that we will insert.
Thanks.
Hey, everyone. My name is Lee. I'm a dev at Euler. So if anybody wants to hear more about our shitcoin pools or thoughts on oracles, I'm happy to chat. My question is for Mudit. What do you view as the solutions to the problems that arise with TWAP oracles, I guess both with and without the additional problems that arise with the merge?
For sure. So there are different components you can fix. For example, instead of using average/mean, you can use median. So that takes away a couple of problems. You can additionally add backups to the price. So for example, you can say by default you use TWAP, but you also cross-check it with some other source and ensure it hasn't changed more than X% from that source, or you can even just time it that there shouldn't be more than X% change between two values, between two blocks. So you can remove these anomalies or manipulated values. Like if you are, even with median, if you are taking multiple values and averaging them, you just average, let's say, the 95 percentile rather than all of the values. So that would remove the manipulated stuff. And that way you can build a secure TWAP system, but in practice, it is very gas complex and it's a very complex system to build. We might have something like that in the future. I know Euler is working on something, but right now it doesn't exist.
Quick follow-up, I was going to ask, what do you view from the technical side? Where do you see this coming into play? Is this sorry, just to repeat that, from the technical aspects, do you view this as being involved in sort of new version of DEXs or something built on top of existing exchanges, or what do you see as sort of the mechanism to it?
Yeah, so on that, like if you use the existing stuff, you can still build a median-based oracle, but it will be gas prohibitive. It won't be practical, like querying all of the values one by one and stuff. We might have a future primitive in the DEX or AMMs themselves that allow medians to be calculated more easily, or they might have a native system which like does the mean or median only on 95 percentile or whatever you define in the pool. So something like that in a new AMM or DEX can definitely be built. Would be interesting to see if someone builds that.
I guess I add one thing, which is one thing I add is in concentrated liquidity pools, you could actually rebalance around certain events to cause the cost of manipulation to go up. So when there's certain types of trades greater than a certain size, you sort of make the oracle act like a batch auction and freeze, or you rebalance. If let's say it's mainly protocol and liquidity, the protocol upon observing a trade could actually rebalance its liquidity. So let's say Aave was using, just as a hypothetical example, let's say Euler or Aave was using a Uniswap TWAP oracle, but the protocol was actually providing 50% of liquidity to the Uniswap pools. Upon seeing a price update, the protocol could compute how it should move its own liquidity within that oracle to such that it has some property that the lower bound of manipulation cost is always greater than some amount. So there's definitely a lot of things like that that can be done if the protocol itself actually owns some of the liquidity in the oracle, which I think we'll start seeing more of in the future. A slightly different answer to the same thing.
That is interesting.
I was curious, what about using a VWAP rather than the TWAP?
So VWAP are even more easily exploitable because then like time is something you can't manipulate on chain. You have to wait for the next block to mine 13 seconds later. But volume is something you can easily manipulate. You just you take the price to a manipulated value and just you keep going back and forth in the same transaction. So they are more easily exploitable. I don't remember the protocol that got hacked with VWAPs, but there is one protocol that got hacked like 4 months ago. They were using an off-chain VWAP and got wrecked this way.
Thank you.
Yeah, a question for Tarun. So, do you think insurance underwriters can use the formulas in your presentation to price the insurance for covering some DeFi lending pool?
I wouldn't do it right now.
What's the reason why you don't do it right now?
I mean, couple things. One is I said, do you have to have these sufficient conditions for these certain types of like bounds to exist? I think we only understand them for a small set of protocols, right? And as people are adding in new, more complicated shitcoin pool TMs, I would certainly not want any of the cross-margin risk from that to bleed into my underwriting calculation, to be honest. And it's very easy for that to happen. So I think like this is the direction towards that, but I don't think we've reached the pinnacle of actuarial sciences in this space. We're very far from that.
Hey, Tarun. My name is Usman. I have a question about the way you constructed or evaluated the probability of the Aave attack succeeding. So if I understand correctly, you created essentially an inequality that represented whether the attack is profitable, and then tried to evaluate create a probability space there around that inequality, and then sample from it to see whether the attack had X probability of succeeding. Is it?
Yeah. So the way we actually did that was we did model all the different borrowers in the system and the different lenders, and we ran simulations as a way of where the stationary distribution of these simulations gave us sort of the probabilities of Q star, QM, C. And then from that, we looked at whether the bounds were satisfied and like what's the probability of the bounds being satisfied under different volatility conditions and then different liquidity conditions. So look at, say, the top K pools, assume that like a certain set of LPs were actually one LP and they all pulled at the same time. How much does that lower C or increase C? So there was a lot of that, and then we sort of did like a hyperparameter search of that to see what the max profit was.
Okay, got it. Yeah, that was exactly my question. I assumed do some sort of like MCMC
Yeah.
to sample, and then I was wondering where you or how you constructed the data that you sampled from.
Most of it's on-chain data for historical data for those borrowers, and then for the Byzantine case of like top X removing, those were sort of hand-tuned strategies. So those are not like reinforcement learned or anything like that.
Okay. So the last part of my question is, do you think that like applying this strategy in the future, where are like the foot guns here? For example, I imagine if you try and sample over a space of attacker balances, it's
Yeah.
easy to accidentally model a flash loan size balance as a 6 sigma event or something,
Yeah.
even though a flash loan is a
Oh,
near
well,
certainty.
no. I mean, you actually sweep the bounds that are possible on chain, right? Because like you know how much liquidity is in Aave
Yeah.
at right now. And so you actually just sweep through like what the upper bound is. So you're asking more from the prospective case of like, I'm making a new protocol, how do I design it? When you're debugging a live attack, you actually know what the current state is. So you actually have very strong bounds on that, if that makes sense.
Yeah, that makes sense. Sure, thanks.
Do we have any other questions? Any curiosities for the panelists? No? No? Okay, I have one question for the three of you. So I know the three of you are all doing, cutting edge stuff in different ways, and a lot of it's like magic to someone who's not expert in these specialties. So taking the flip side and creating a little bit of trouble for our peers here, I was curious, what do you guys think is the most ineffective thing that people are using today? Right? Commonly, very commonly, multiple people in the crowd should be using it. What are people doing? Like, obviously, you all have your specialties, but what are they doing that they shouldn't be? That's just a waste of time.
That's a very interesting question. So, within Solidity, there are a bunch of things people keep doing that are not effective at all, or have gotchas like safe transfer. It's not safe at all. It has its feature, but it's definitely not safe. Some other things like even safe math, I still see people using safe math in Solidity 0.8. 0.8 already has safe math built in. You don't need to add anything more. I think that's two things.
Well, I want to say too many optimizations, but I understand the other side of it, of like gas optimization. So can we make the gas down and leave the programs nice and clean? So yeah, that's my...
I guess three things. The first is writing an AMM and not taking a numerical analysis class and not understanding how rounding works. I mean, 18-year-olds understand how that works. So I don't understand how you want to put $1 billion into something that rounds incorrectly. I wouldn't do it, but yeah, I'm happy that I'm hoping more people actually learn some basic, how do I do the Remez algorithm or how do I do things like that? Should be lingua franca if you're going to put real money in something. The second thing is a lot of zero knowledge proof systems. I think there was this amazing set of bugs that 50% of the implementations had, where the fiat Shamir heuristic was not implemented correctly, and it wasn't checked. I think sometimes in a lot of core cryptographic things, people kind of implement exactly the algorithm that's written in the paper, but the paper doesn't add in certain verification steps, and some of the state used gets reused, and there's a lot of 0 days. So very much checking how you implement a paper directly, especially in ZK land, I feel is even in some of the ETH ZK contracts, the zero knowledge airdrop, there were just some really bad basic mistakes that I feel suggested someone just read the paper, wrote the loop and wrote the branches exactly as the paper said, which doesn't work in your current state machine. And then the third thing, I think some of the auditors said this yesterday about people who kind of do very ad hoc, probabilistic simulations and then think that they're going to make a algorithmic stablecoin that lasts forever. I'm like, first of all, you fucked up point one I made, which is you didn't do the rounding correctly because you wrote in Python and like you're fucking rounding in the EVM. Are you like, did you like even look at what you're doing? Did you look if the numbers matched? But then of course there's the litany of all the other basic errors you see and doesn't, leads people to think that they just found a way to have a perpetual motion machine.
That reminds me, one point I'll add is purely governance tokens. You still see projects just launching governance tokens, which make no sense. Decentralized governance in general is very immature, and those tokens shouldn't really be valued at like billions of dollars for having right to own another $1 billion of tokens to create a proposal. Just doesn't make sense to me.
I see that you don't like the VE model.
Not too much.
We gotta be careful because we're starting to expand. We can find so many things wrong with what people are doing if we start going past security. But that's time. So thank you, everybody, for your contributions. We learned things we should do and things not to do. 20-minute break, back at 2:25 with Richard from One Confirmation. Thank you.